Hi, I am Luke DeSmet, part of the Oros Americas support team. I will show you how to perform vibration diagnostics on a rotating machine. If you have any questions, please send an email to info@oros.com.
Now I will show you a demo of Orbigate. The scenario is that I'm out in the field and I've set up my sensors and my clearance circle. I have just finished taking my measurement, so I switch to navigation mode and load my results. Orbigate allows me to call back any results regarding transient speeds. I am also able to call back the speed profile. I would like to overlay the 1x RMS and the overall RMS. I expect to have the same plot because I assume that the resonant energy will follow the 1x. However, as you can see, that is not really the case here. You can see that I have a deviation between 3000 and 4000 RPMs. I would like to understand what happened over this large range. I therefore will display the order spectrum. To do this, I select the Add Windows function for Orbit and choose the order spectrum of my Y probe. This allows me to use my cursor in order to browse my measurement. This function is very convenient. On the far right graph, you can see that I can browse through my speed profile to speeds greater than 3000. Just before 2000 RPM, I have only 1x, as you can see on my order spectrum. But as soon as I enter into this speed range, I have one subharmonic. You can see this subharmonic has an order of 0.375. So it appears that I have an oil instability. I therefore will display the orbits to check for an oil instability and will make a report to send to my team. To do this, I will add my whole orbit. You can see that this orbit is not closed. As Nick said, you will need more than one orbit in order to close a cycle. At 0.375, I need roughly 3 revolutions to complete one full cycle. I can easily go through the Analysis tab settings and display 3 revolutions rather than 1. I do not need to play back the signal, I simply ask the software to display more. We can now see the orbit is closed. It is time to generate my report. For this example, I will select a template with one graph per page. I rename it Web1 Sub 1x and I open the report, which will generate and open the report. The next report that I would like to edit is the critical speed. You can see that at roughly 4,700 RPM, I have the phase rotation plus the magnitude amplification. So I'm interested in knowing the S max for the orbit and the critical speed. Therefore, I create the sub 1x report. Here is my template with one graph per page. My report is ready to be sent to my colleagues. So now I will focus on the resonance near the critical speed, so I will show only the results without the oil instability. I would like to have S max, so I select the S max data because I'm interested in getting the size. Therefore, I put the cursor exactly on the critical speed. I now have the S-max, the Bode plot, and the orbit shape, so I can now generate my final report, which will be named S-max. You can see that in a few seconds I can generate at least 2 reports, which takes approximately 1 to 2 minutes, ready to be sent. As you can see, it is convenient to first do diagnostics in the field and then quickly generate reports before leaving the job site.